solve a problem by using two-pointer approach. But before this, here are some checklists so that we can recognize this question is going to use by the two-pointer approach or not. So first of all, array should be given as sorted array, and it will say like find a pair or find a triplet, find a palindrome, reverse an array or string, remove duplicate, merge two sorted array, move elements, or compare from both the end. If these kind of questions are there we can consider and we'll think maybe here, or we can surely say like 80% chance is there will be resolved by the two-pointer approach. Let's solve this two sum problem so we'll get a better understanding on the two-pointer approach. In this question, what are the things are given? We have given with a sorted array with non-decreasing order, and we have given with a target, the sorted array with the numbers, integers. So we have to find two numbers. We add this, added up, it will be equal to the target. Let's take an example. We are having an array with sorted manner 2, 5, 6, 9. Now you have given a target 14. Now we have to find two numbers. When we add those, it should be 14. You can see 5 and 9. This will made of a 14. So this will be the answer, 5 and 9. The answer might be the index number of this element or the number itself. If the index number it is asking, we have to write 0, 1, 2, 3, 4, right? So the answer should be 2 and 4. And we have to return as an array. From this question, we can go to our checklist and check. Here we are given with a sorted array and it is asking us for find a pair. So this might be solved by the two-pointer approach. For jumping into the two-pointer approach, first of all we will think like a normal person and we will apply brute force approach. Brute force thinking means we don't care about how much time it is taking and all. We just focus onto the solving the problem. Now here is our array. How we'll think? We will start with the first element here and we will add with the next one, 1 plus 2. How much it is giving? 3. Now is this equal to the target? 3 equal to the target 14. If no, then we will move to the next element, 1 plus 5. Is this equal to 14? No. Again we are moving next element. Now if it is not possible in the first index, we will move to the next one, 2. Then we will start with 2 plus 5, 2 plus 6, and we will check each sum with the target. If it is not there, we are moving forward and forward until we find the answer. So the code will be like here for I equal to 0 and I less than, up to here we are moving, n minus 1. N is the size here, array size, I plus plus. Inside that we'll start with the next element after the I. For j equal to I plus 1, j is less than n minus 1 and j plus plus. Here we'll write the logic, array of I plus array of j equal to target, then return I and j. This is the brute force approach. Here it will give us the right answer, but for each element we are traversing from 0 to n, so the time complexity will be n square. Now we'll try with the two-pointer approach and we'll see how it is decreasing the time complexity. Now we'll understand the two-pointer approach. This is our array. The indices will be 0, 1, 2, 3, 4. Now in two pointer approach, what we used to do, we are giving two pointers. Here one pointer left, here one pointer right. Now left and right we will add up. Left is our 1 plus 9, which is 10. Our target is matching? No, it's not matching. So we'll move forward. Now we have two options. We can move the left pointer, we can move the right pointer. If we move the left pointer, what will happen? The left pointer will goes to number 2, right? Here it was, now it will move to the 2. Plus we have not moved the right pointer yet, so the 9 will be same only. The result is 11. Still this is not same answer. Now we'll, instead of moving left, we will move the right to the backward. So what it will be? 1 plus 6 equal to 7. So this is when we left plus plus, and this is when we right minus minus. This is in the same position, like after this 1 plus 9, if we move left to the forward, this will be happen. If we move right to the backward, this will be happen. By this operation we will conclude one thing. This is our first sum, like first sum is first sum, you must have to do it. First sum is 10. When we do the left plus plus, what it came? 11. When we did right minus minus, what it came? 7. You'll notice something here. From the first sum, when we do a left plus plus, it is more than the first sum, more. And when we did a right minus minus, it is less than the first sum. Get, when we are moving left plus plus, we are getting bigger element, and when we are doing right minus minus, we are getting smaller element. So the current target is 14, right? We are getting 7 here when we move the right. When we move the right, we are getting 7. Again, if we move the right, we will get lesser number. So we will not approaching to the target. But when we are moving the left plus plus, we are getting more higher number. So the next sum is 11, right? So it is close to the target. Now what we have to do, according to the target, we will move the left or right. If we want a bigger number, greater number, then we will move the left, and when we want a smaller number, we will move the right one. So let's see. Our array is 1 2 5 6 9, right? One more time we'll write here. 1 2 5 6 9. 0 1 2 3 4. So first sum is 1 plus 9 equal to 10. Our target is 14. Now we need larger number, because the 10 is less than 14. The first sum is less than 14. Larger number, what we have to do? Left plus plus. Here first left, right, and sum. So the first sum is 1 1 and 9. Sum is 10. Target is here smaller or greater. According to that we will move. Target is 14. So this sum is smaller than the target, right? We'll move forward. What do we have to do? Left plus plus, as it is smaller. Left plus plus means what will be the position? Before this was the left, this was the right. Now left plus plus means this will be the left and this will be the right. 2 and 9. 2 and 9 means 11. Still it is smaller. We need a larger number. What do we have to do? Left plus plus. So here is our next left will come. Right will be still there. Now the number will be 5 and 9. 14. Here we can match our target. So the number will be 5 and 9. If you want the index, this will be 2 and 4. This will be our answer. Point we have noticed here, left should be start with the 0, right should be start with the n minus 1. N is size. Then we are doing a sum, right? Sum is equal to left plus right. We are having a target when sum is less than target. Less than target means what? We want a greater number. So if we want a greater number, what we have to do? We have to do left plus plus. So when sum is less than target, we have to do left plus plus. And here, if the sum is greater than target means what? We want a smaller number. So what we have to do? We have to do right minus minus. And the third scenario, we are finding the sum equal to target. That will be your answer. One more thing we have to think about the traversing. Up to how much we have to traverse. So here is our left and right. We are going and we are just going like this, and we are just coming right from like this. So left and right meet. They cover all the element, right? We didn't find the element. If we found the element, we'll stop that. So up to where we have to come? When left is less than right. Here they will meet each other. The left and right, when they meet, we have to stop the loop. If we found the result, then it's fine. If you don't found, means the element does not exist here. So this will be the point. If we go more than this one, means there is waste of traversing, because this element has always already covered. Code here to sum will give with an array, integer array, and a target. Now first of all, we will declare the left and right pointer. Integer left 0, right equal to n minus 1. So n is nothing but the size of the array. Here you can declare int n equal to arr dot length. Now we'll start the loop. While what we have discussed, left should be less than the right. First of all, we will bring out the sum. So sum will be array of left plus array of right. Now here we have three possible situations that we have already discussed. When the if sum equal to target, then we will find the answer, right? So we will just return new int of left and right. So this is the condition number 1. The next condition will be if sum is less than target. If the sum is less than target, then what does it mean? We need greater value. If you need greater value, then what we have discussed, then we have to do left plus plus. You can see if the sum is less than target, left plus plus. So that same thing we have written the left plus plus. then then the last condition, else. Else means what here? The sum is greater than target, and when sum is greater than target, we need smaller value. So inside this we have to write minus minus. So this is going to be your answer. When the sum, again it will find the sum, it will return the position, it will return the array. Here the time complexity will be right max to max how much it will move, and left also n. So the time complexity will be big of n, and the space complexity big of 1. We have used only the integer. We have only used. Now just go and try to attend this question. I will attach the link from the lead code for this question to sum, and just watch the video and try it by yourself, and we will see you in the next lesson with the question reverse string with the same approach to pointer. Okay.